Hello, math people. Middle of the week, ready for some more 2D geometry. What have we done so far? We've done area of parallelograms, and we've done missing measures of parallelograms. We've done area of triangles, and we've done missing measures of triangles. And now we're headed towards trapezoids. If you can remember, the very first day we started this, we were talking about the different polygons we were going to be exploring. Rectangles and squares are old news. You've done those. This year we've done parallelograms, we've done triangles, and now we're moving on to a fun one, the trapezoid. So for our notes today, I'm going to go through how you find the area of the trapezoid and a couple pointers in doing this. And then I'll do a couple examples, and then you're off to the races to do some practice on your own. So first off, up here in the top right of the screen, we've got two trapezoids. We've got this green one, and we've got this purple one. Sometimes you're going to see trapezoids that look similar to the green one, where one of the pairs of sides forms a right angle. So that means that this side right here is a straight side. This goes from top to bottom straight. It's important to pay attention for that in a trapezoid. So before I get too ahead of myself, what is a trapezoid? Like, what are some defining characteristics? A trapezoid is a polygon that has one and only one pair of parallel sides. So you'll notice in this drawing of a trapezoid, the green one, there is one pair of parallel sides. It goes right here. The other pair of lines, the other sides, are not parallel. And if they were, this would not be a trapezoid. In the purple trapezoid, we again have one and only one pair of parallel sides. The other two sides are not parallel. All right, so let's get into it. Another thing we should talk about is the parts of a trapezoid. So if you can think about a triangle or a parallelogram, we used terms like base, we used the term like height to describe like measures within the figure itself. A trapezoid is similar in that it has some measures that we should become familiar with. So in a trapezoid, there is not one, but two bases. Two bases. And the bases are always going to be the two sides that are parallel from one another. So in the green figure, that would be this side at the top and this side at the bottom. The way that we identify the two bases is we call one of them base 1 and the other one we call base 2. But in geometry and in math, we frequently will use symbols or like shorthand ways of writing this. So base 1, you will always in a trapezoid see written like this, B and then a teeny tiny little 1. And base 2 will be written with a B and then a little tiny 2. Those little numbers are not actually numbers. Like, they're not exponents, they don't do anything. They're just there to distinguish B1 and B2. It's like little labels. So when you see those numbers, they're not actually numbers for the problem. They're just labels. We can't call them both just base. We have to have one that's base 1 and one that's base 2 because you'll notice they are different lengths. This one is shorter than this one, so we can't just call them both b. If they were the same variable, that would mean that they are the same measure, and they are not. So one of them will be known as b1, base 1, and one of the sides will be known as base 2, b2. It doesn't matter which you call which. They're interchangeable. So if you want to call this top b1 and this b2, and your dog wants to call the top B2 and the bottom B1, it doesn't matter. You're both right. It's interchangeable. And just to reiterate what I said initially, which two sides are the bases? Always and forever, it's going to be the two sides that are parallel from one another. So in the purple figure, that would be these that I just outlined in black, B1 and B2. The height, let's talk about the height in a in a trapezoid. I'm sure that you can probably guess what I'm about to say, but the height of a trapezoid has to be straight. It can't be one of these slanted sides. It's going to be the straight distance between B1 and B2. So in the green trapezoid that's here, that's going to be this side. This would be my height because it's straight and it's connecting B1 to B2, base 1 to base 2. And in the purple figure, it's going to be this red line. And I know that it's straight because it forms a right angle. So that tells me this is a straight line. So this is going to be my height. And one of the bases we'll call B1, and the other we will call B2. These are the only measures that you're going to need when you are calculating the area of a trapezoid. So the area of a trapezoid is going to be written in this formula. The area is equal to the base 1 plus base 2. So we're going to find the sum of the bases. Sum means add. We're going to add the two bases together. So whatever this measure is and whatever this measure is, we're going to add them together. We're then going to multiply that by the height. So B1 plus B2, we're going to find that first. That's why it's in parentheses. We're going to solve that first. Then we're going to multiply that by whatever the height is. And lastly, we're going to cut that whole thing in half. So we're going to multiply that whole product there by 1/2, and that's going to cut it in half. Similar to a triangle, you could express this formula slightly differently if you wanted to. You could do base 1 plus base 2, multiply that by the height. And another way to cut something in half is to divide the whole thing by 2. So if you want to write the formula this way, you're welcome to. In this way, you'd be adding your bases, step 1, multiplying it by the height, step 2, and then taking that whole product and cutting it in half. I kind of prefer using the fraction 1/2, but it's totally up to you. So the formula for finding the area of a trapezoid is half of the height times the sum of the bases, B1 plus B2. So let's look at that in practice. Let's do some examples. It's always good to see stuff worked out. Here's that green trapezoid from above. I've given it some measures, and I'm also going to label these things. I'm going to call this B1, because why not? And this is B2. You could change that up. Why does it not matter? Because you're going to be adding the bases, and it doesn't matter which is B1 and B2, because in the end, you're just adding them together. And then 6 would be my height. So the formula is half of the height times the sum of the bases. So let's just fill in what we know. We know the height is 6. We know the bases are 5 and 9. And now we're just going to do a little math. First, in my order of operations, I'm going to add 9 plus 5. So that's going to leave me with 1/2 times 6 times 14. You can do multiplication in any order that you want. So you could do 6 times 14 first, and then multiply that by 1/2. You could do 1/2 times 6 or 1/2 times 7. It doesn't really matter because multiplication you can reorder and it doesn't change the final product. I'm just going to go in order for this one. So I'm going to do 1/2 times 6 is 3. And then my last step here would be to multiply 3 times 14, which is my favorite number, just randomly. The area is equal to 42. And since it's area, let's make sure we're using proper labels. That would be square feet, so feet squared. And there's the area of the trapezoid. That's how much space is green within this figure, 42 square feet. All right, I'm going to do one more. If you're a person who likes to challenge yourself and see if you've got it, feel free to pause the video and see if you can set this one up, and then we'll go through it. But I'm going to start with the formula. Area equals 1/2 times base times the sum. Oh, I wrote that wrong. Getting ahead of myself. Half times the height times the sum of the bases. All right, fill in what you know. This is one of the bases, this is another one of the bases, and the 5 is the height. So here we go. 1/2 times 5 times 11.5 plus 8.5. So as a first step, I'm going to add the parentheses together, 8.5 plus 11.5, which is 20. So now I'm at 1/2 times 5 times 20. And in this scenario, I think it's easier to multiply 5 times 20 because that's 100. So that's going to be 1/2 times 100. And then half of 100 is 50. So in total, the area of my purple trapezoid is 50 square meters. 50 meters squared. And that's it. That's how you find the area of a trapezoid. And, since it's math and I love it so much and I love you all so much, I decided to also give you a little word problem version of this stuff. And I thought this one was cool for a couple of reasons. One is we've got this crazy pandemic going on, and a lot of people who are trying to figure this out and trying to keep people safe are trying to um, calculate how many people live in a certain area within states, because then they can have a better sense of how to control what's happening and how this thing is spreading. Another thing that's happening that's probably not on anyone's minds, considering the virus, is we have an election coming up, which you might not care about, but a lot of people do. And why elections matter is people like to track how people are going to vote within states and within parts of states. So this is an interesting problem. This is a real place. If you were to look at a map of the state Virginia and then zoom in so that you could see where all of the counties are, there's a county in Virginia called Scott County. And it's not a perfect trapezoid, but the approximate shape of Scott County is a trapezoid. So you can use the area of a trapezoid to help answer this question: how many people, and I'm getting this question from right here, how many people are there per square mile? That means if you could take Scott County and break it up into little tiny squares where each square is 1 mile in size, how many people are there in every square mile? So if I've got a trapezoid and I want to find out how many people are there in every square mile, I first need to find out how many miles are there in total in Scott County, aka what is the area of this county. So since it's a trapezoid, I'm going to use my trapezoid formula. Area equals 1/2 times the height times the sum of the bases. So let's fill in what we know. What we know is the height approximately of Scott County is about 20 miles, and the bases are 15 and 38. And the sum of 15 and 38 is 53. And in this scenario, I think it's easier to multiply 1/2 times 20. So I'm going to do this multiplication first. Half of 20 is 10. And then 10 times 53 is 530. So let's focus ourselves. What did we just find? Well, we found the area of a trapezoid, which happens to be Scott County, Virginia. So the total area of Scott County, Virginia, if we were able to fill it all in, is 530 miles. Scott County is 530 miles, square miles in size. But I want to know how many people are there in every of those 530 miles. Well, here's an interesting factoid. The population of Scott County is about 22,100 people. If I want to find out how many people live in every mile, I'm going to take 22,000 100, and I'm going to divide that into, break that into groups of 530. So then I'm going to know how many people are in every 1 mile. Taking the people and I'm dividing that into 530 square miles. And if you were to use a calculator or sit there and do long division, no matter what, it's going to be about 40. Let me double check. I think it's 43-ish, 40, 22,100 divided by 530. It's about 42 people, give or take a little rounding. So I'm going to say this little symbol, squiggly equal sign, means about 42 people per square mile. Anyways, this is a little bit of a multi-step problem, but the basic part of it that applies to what we're learning is that county is the shape of a trapezoid. You can find the area of a trapezoid, and then you can use that area to answer some interesting questions. And in this particular instance, it was how many people live in every square mile of that county. Anyways, I got a little carried away there. Hope you got the basic gist of this lesson, which is to find the area of a trapezoid, use the formula. Good luck practicing today. If you have any questions, message or reach out. Otherwise, happy hump day, as they call Wednesday. Enjoy doing great math things.